So I've created a new file called LED Advanced, and in this file we're going to use pulse width modulation, which is a technical term that you don't need to understand, in order to control an LED. And basically it means that we can control the brightness of the LED. So let's go with this. We're going to go from GPIO 0, so we're going to import from our library, and we're going to import PWM LED, which stands for Pulse Width Modulation LED. And let's go from time, we're going to import sleep. Okay, so now we're going to go for our LED, and we're going to set up our LED for our right hand side. So underscore front right, just so I can see what I'm doing, is going to be equal to a PWM LED on, for me, it is 25. That's what it was last time. And now we're going to go try while true, and we're going to then go LED underscore FR dot on, so we're going to turn it on, and then we're going to press backspace to get to here. We're going to type in our accept, and we're going to type in keyboard interrupt, and when we get our keyboard interrupt, we're going to turn LED underscore FR dot off. So let's start with that. So I'm going to save that now, and then I'm going to press run current script, and you'll see that the LED turns on, and when I press stop, it turns off. That's fairly straightforward, and it hasn't actually changed much since we did the last thing, but this is a good setup for starting our program. We've got our imports, we've got our try and accept, and our while true happening. So we're ready to go for actually setting the brightness. So now that we've got that set up, we can actually change this, and we're going to change this like so. We're going to go LED underscore FR dot value is going to be equal to 0. Then we're going to go time dot sleep for 1 second, and then we're going to go LED underscore FR dot value is going to be equal to 0.25, and then we're going to go time dot sleep, and we're going to sleep for 1 second. Then we're going to say LED underscore FR dot value is equal to 1. Then we're going to go time dot sleep for 1 second. Okay, and I'm going to put a note here that the value can be any number between 0 and 1 inclusive. Okay, so now that I've got that, I'm going to hit save. I'm going to hit publish or run current script, and I've got an error there, time.sleep. That's an old habit of mine. You didn't used to be able to do this. You used to be able to have to write time.sleep, but now I've got sleep there, so there we go. I can just do that and hit run, save, and then run current script, and I can see that the LED gets dark and then brighter again, and then turns off again. So basically that is setting the values. Now with these LEDs, the way they're set up, most of the fading happens in the first 50%, so the last 50% isn't very fadeable, if you know what I mean. So basically that's because I need to put a resistor on them to make them a little bit nicer. But basically that is a way of setting up our LEDs to change their brightness. In order to complete this activity, you've got a few things to do. To get satisfactory, all you have to do is show the teacher the code and the robot LED demo as per the tutorial. The next thing you need to show the teacher is to show the code and demo for all lights working at different brightness settings. So that's all 4 lights. Now, if your robot has LEDs that are broken, you only show them the ones that are working. You need to then ensure that you have cleaned up all your PWM LEDs before you finish your program. So when you press the stop button, they should actually clean up. To get exceptional, you need to create your own useful custom PWM LED functions where 2 or more lights can be set to give brightness. For example, the command front lights open bracket 0.25 will set them to a 25% brightness. Once again, you have to make sure that you clean up your PWM LEDs, but this time with a single function.